Hello, everybody. This is our next webinar about object-oriented programming, the webinar number 51. That's a pretty big number, actually. I was looking today at this announcement for the webinar, and I realized that the number is pretty large. So I was doing these webinars last year and a few years before, and I was trying actually to do them every month, but this year, a little bit more work, and I keep forgetting about them. So that's why I'm asking you if you can remind me about them. Well, I schedule them, I put them on the blog, I announce them, and then I somehow miss them from my agenda. And if you can actually remind me in the Telegram channel or in the Telegram group we have, or in the Twitter, or basically there are two channels, Twitter or Telegram, then that will be very helpful, so we're not going to miss them. So the idea is to do webinars every month, every first Wednesday of each month, and they all have to be dedicated to object-oriented programming. And I have something to share with you every time, so please stay with me, please remind me, and we're going to do it every month. So this time we're going to talk about two different approaches to design of the objects. So how you design your objects, actually collections of objects. And I wrote a blog post about that this year, a few months ago, and I called the two approaches the fat design and skinny design. So I'm going to show them now, and you may be able to ask questions, and we're going to discuss them in details. So to explain you the difference and to explain the idea, I decided to pick a different business case, different from what I mentioned in the blog post. So in the blog post, we're talking about the collection of objects which are supposed to retrieve data from a relational database like Postgres database. But this time we're going to discuss JSON parsing business case. So let's say we have a JSON document which is in front of you right now, and we want to parse it in Java. So this time we're going to use Java. So let's say it's just JSON with just one element, this one, and then the array here. So to parse this, so let me maybe copy it so you don't lose it. So if you go for here and you post it here, so let's say it's Java. So to parse it in Java in a traditional, not really traditional, it's called, as far as I know, it's called JSON API from Java, I think 7. So that's how they recommend you do it. So you do JSON reader, you call it reader, and then you say some input source, I don't know, input stream, for example, the input stream. And then you do reader dot read object, and you get the object, and it's JSON object, I guess. And then you say object dot get string, and it will gonna return you the title, and you do title, and then you do, let's say you want to read the array, so you do JSON array. Let's be more object oriented, so you do quotes, and then object get JSON array. I don't remember exactly the syntax, but I think it's something like that. And then you do quotes, get values as something like that, I guess. Maybe, I'm not sure about that. Maybe it's this. Yeah. So so that's the way Oracle from the JDK recommends us to read JSON. And this is what I call fat design. Why it's fat? And what's going on here? So let's see. So in first line, we create a class which is, well, JSON reader is the interface. So this one is the only class probably here. So here we're going to create a class which implements this interface. And then we ask this class to read an object. So I suppose that JSON parsing is happening here. So the entire document is being parsed, and what is created here is a pretty large in-memory structure, which contains everything that was found in the JSON document. Everything. The title, the quotes, the array, everything. And then you go for object get string title, and we get into, let me turn on the phone so I don't miss your comments, if any. So you read the title from here, and what's happening here is probably the title is coming out from an in-memory structure. So the input stream is not being touched here. No touch of the stream here. I'm 100% positive this is what's going on. So we take it from the in-memory structure already pre-parsed. Here, the same story, no streaming, no reading. We just get the in-memory structure and return it here. And then we, again, no streaming, and you just deal with something which is stored there. The beauty of this, well, maybe I can give you first the alternative design, then we discuss the difference. So let's take a look how it can be done in an alternative way. What this one is called, I would call it fat design. It's fat because this class is pretty large. So this method, read object, is pretty fat. It's pretty big. It takes everything, it reads everything, it stores everything, and then in order to get access to what is being read from there, we need to make sure that the JSON object has all the necessary methods like getString, getJSONArray. So these two methods, they have to be there. They have to be in the object which we create here. So we parse and we return an object which contains as many methods as necessary for all our users. So we don't know at this point, at the point of read object, we don't know who is going to use the object and how. We give them all the features. We give them getString, we get them getJSONArray, we also can give them getJSON object, so it also exists there. And if we would need more in the future, we will also need to put it there in the object. So the object is coming in a fat way. It's coming with everything together, with everything implemented already. So the object has all the possible access points for the future. It is possible to create a different design. Let's call it skinny design, which would look differently. Let's see how we can design the same idea but differently. Let's say we do JSON objects. This is not Java. It is not JDK. It is Java, but not JDK. So we do obj equals to new JSON object stream, and then we do object dot get JSON array. No, sorry, not this way. We do it this way. Object JSON. Yeah, to do the string, we do this object dot get element title and then for array we do JSON array quotes new JSON array. And then the same story, get values. So here, what I'm doing here is that I create an object, JSON object, probably in a similar way to what we've done before. It doesn't really matter this line. But here, in order to retrieve the title from there, I say object get element title. Take a look. I'm using get element here and I'm using get element here. So it's the same mechanism of retrieval of something from from there. And probably this one should be string, and this one also should be string. So I'm doing parsing here. I'm just explaining now what's going on, and then we're going to discuss the differences. So the parsing is happening here, and parsing will happen here as well. So I'm doing parsing 2 times. This line parses. Sorry, you probably don't see that. So let's break it to the next line. Yeah. So I'm doing parsing in both places. So here parsing will happen, and here. In both places, we're going to do the parsing. So the object will go to the stream when I call getElement.title. It will take the part of the document. For example, in case of getElementTitle, it's going to take this part. And in case of getElementQuotes, it's going to take that part as a string. Pay attention. And then the string will be encapsulated in JSON string or in JSON array. And when I say get value, or I say get values as string, then the actual parsing will happen again, the parsing of this data. And they will be presented to me as a string here, or as a collection of strings here. So the beauty of this approach is that the object, the JSON object, exposes only one thing, only one method here. So the class, the interface JSON object is very skinny. It's small. It's much smaller because it doesn't have getString, it doesn't have getJSONArray. It just has getElement, just one method. And it exposes something that it doesn't understand what's inside. So the JSON object doesn't know anything about what is array and what is string, because here it knows that. Here it understands the difference between a string and array. But in this case, JSON object is pretty dumb and pretty simple, much simpler object. It just, we ask it to give us the element, the JSON element, and it just returns us the whole string, like this one. Take it. And then we parse it. So in this case, we have the complexity. Here, the complexity is concentrated is probably in this method. Everything that takes time and the most, all the calculations and all the difficult things are happening here. While in other objects, probably they are just simple data structures. So here, probably this JSON array, the implementation of JSON array is quite simple. It doesn't know how to parse JSON. It only has some list inside encapsulated inside, and it only returns what's there. In this case, it's different. The complexity is spread over multiple places. The JSON object knows only how to parse an object, but it doesn't know what to do with the elements of the objects. It only knows that the element is title, and then whatever is coming here, it is for the future. So it only can return you this thing, and then it's up to you how to parse it, how to understand it, how to interpret it. Maybe it's again an object, maybe it's a string, maybe it's an array. So there's 2 designs. So what are the differences and why I think that the second design, this one, the skinny one, is better than that one? So the fat design has disadvantages. And I'm going to name you 4 things why skinny design is better. So the first one is basically and that's what I said in the blog post, the first advantage is that it is much easier to extend it. So let's say tomorrow I want something else. Now I have getString, and then I have getJSONArray, and let's say I want to, for example, there is a new specification, and for example, JSON will enable something like I don't know, something like Boolean. Let's say true. I don't think now it's available in JSON, so let's say JSON enables this Boolean values. So in this case, we will need to modify the JSON object element. So we will need to, JSON object interface will have to be extended because we will need to add something like get boolean, and then the entire, basically the entire hierarchy may need to be changed. Like one object, and then who knows who is implementing this object, because this is interface, who is implementing this interface. So we will probably need to update the implementation of the JSON reader, and then who knows how many other implementations we have for this JSON reader, and how many implementations we have for this. So all the specifications, all the implementations of this API will have to be updated to be able to parse a Boolean. In this case, we just introduce just one new class. That's all we do. We just say, that's it. We just introduce one new class, and we say JSON Boolean, and that's it. Boom, get value, that's it. So we just add a new class. That's all we've done. We just added new class, which is able to work with a string. We do the same extraction of the data from the object. Nothing changed. And anyone can do that. So let's say we have an implementation of the API, and this implementation doesn't have the class we're looking for. So then we do the then we add new object, and that's it. So extendability is much higher. That's my point. In the first case, extendability actually suffers because the entire hierarchy of classes which implement the interface, and a few interfaces actually, they all depend on it. So modifying interfaces is much more expensive operation than modifying classes. Because interface, expects, there are dependencies, there are classes which depend on the interface. So every time you modify an interface, it's expensive operation, especially when you have multiple implementations of your specification. So let's say you design a collection of interfaces, and then you have implementations, and it could be even inside your own library. You may have like a live implementation, and then you may have a test implementation, then you have some mock implementation. So you may have a number of implementations, and then when you add something in one place, you need to update all of them, and that may be time consuming and expensive when you support your library. So that's one problem. Extendability. So extendability is definitely higher. The second one is cohesion, meaning that at this point, when we do this, then probably the reading, this read object, is quite large, code structure. So it has to include everything. It has to understand many things. How to parse arrays, how to parse strings, how to parse Boolean. And if we add something new to this, we will need to update that. We will need to increase the complexity of this read object. So read object is very complex, and at the same time not very cohesive, because there are many things which actually don't belong to each other. For example, parsing of arrays and parsing of strings, they're different things. They're not supposed to be in one place. They don't really connect. They're not really connected to each other. They may stay separate. They may be separated from each other. This is better to design it this way. So one class is responsible for parsing strings, and another class is responsible for parsing arrays. So putting them together is basically increases complexity and decreases cohesion. So they are not really touched to each other, which leads to functional errors, which leads to problems, to functionality problems, because complexity is high, too many things in the same place, and that's why problems will show up later. So here we have very non-cohesive object model. So in one place we have all the functionality, all the implementation of parsing and understanding the data, and then we let this data go out in this object, so like JSON array, and there, when JSON array is there, it doesn't know how the data was parsed. So the information about the actual source of the data is lost here. So the JSON array will never probably be able to tell you if there is some parsing error, for example, in the stream. So JSON array is pretty dumb structure. It's most probably it's a data structure. It's not even an object. It's pretty dumb, holder and an envelope for data. So at this point, when JSON array is here, it's too late to do anything, to tell anything about the stream and say that it lines something, we had some problems, and so on and so forth. That's the cohesion problem. So we just broke the interconnection between the functionality and the place where this functionality is being used, and it's not really cohesive. It's better to keep things together, like here, like I'm saying here, like the parsing is happening here. So we know exactly that the actual parsing of the quotes will happen right here. And if something is wrong with the quotes, if something is wrong with the array, then this class right here will know what's going on. So the parsing stays closer to where the data is being processed. So this is more cohesive design. I think it's a benefit. Point number 3. Reusability. Reusability, that's very important and very interesting to know that, to say that in this design, it is very difficult or impossible, actually, it is not difficult, it's impossible, to reuse the implementation of JSON array interface. We don't even know where it is. So in this, looking at this library, we only can use it for only one purpose, only to parse the stream, and then from this stream take an array, and then from that array take the data. So it's only one specific scenario in which we can go. Maybe for JSON parsing it's not actually a problem, because JSON parsing is very simple operation, which in most cases, in all cases, it should be done like for JSON parsing. So there is no other possible probably scenarios. But for other cases, it could be possible that we may say that, how about we stop here at this line and say, give me the implementation of this JSON array, and I want to work with JSON array without parsing the whole object first, and then retrieving. I don't like to create this reader, and then from the reader get an object, and then from the object get an array, and then finally I get an array here. So this library is kind of forcing me to follow the specific procedure. In this case, in the skinny design, look what I have. I can easily put anything I want in here. I can say, boom, this is my array, 1, 3, 4. So parse me here. This is a string right there. So I'm easily using the JSON array in the way I want it. So it's a much better reusability. So my class can be used outside of this library, outside of the scenario which is dictated to me by the creators of the library. Or for example, let's say I want to do it this way. I want to do like a file parsing. Maybe like this. So I just want to parse the file, which also could be the case. Or maybe I want to do open the socket here and read from the socket. Whatever, it's up to me. I am free to do anything I want. Here, I can only work with what is allowed in there, and then I go down through the hierarchy of interfaces. And at this point, when I'm here, it's too late to do anything, because when I'm here, look, it's too late to stop and say, no, I want my input as a string to be in there. I have no control. I have no control. The only point of control for me is this one. So they give me only one line, only one place where I can actually control what's going on. And then after that, what's happening is only through their classes, which are even not public. They're not visible. I don't see them. All I see is just these interfaces, which actually not a bad thing to see interfaces. But it would be much better to have classes. I also call them in some articles smart classes, or in the book, in Elegant Objects book, I call them smart classes. So this is more or less like a smart class. So this class is is working with a string, is working with a very simple piece of data, and then understands that piece of data and extends the functionality of the piece of data. So by default, this simple simple string is just a piece of data. So no features there, no additional functionality. And that is enough. So additional functionality I add through the smart class, which not decorates, but which encapsulates the simple data, and then adds the functionality on top of that, making this piece, which was retrieved from the JSON, from the object, smarter. So now it has more features, this JSON object. That's the idea. So in this case, the functionality is hidden in the JSON array, somewhere there. And the only way to use this functionality for me is to basically get it out and then just use what they give me. If I want to change the way the array is being parsed, then that's it. I cannot use this library. I need to write my whole new library. Let's say I want it to work like that, with the single quotes. It's not possible to do it with the traditional JSON library, with the library coming from Java, from JDK. I need to write my own library. In this case, it's possible. In this case, I change the way JSON object, maybe I don't even touch the way JSON object works. I only change this class, JSON string. I don't even change it. I create my own class. Maybe this one is coming from the library, so I create my own class, and I call it JSON5 string. And this JSON5 string will understand, or maybe, okay, there's not it's here, JSON5 array, which will understand arrays in different format. So I have a collection of classes in the library, many of them, and then I add my own class, and boom, this whole library is still there. Just add my own class, encapsulate one of their classes, and it works. In this case, I cannot do it. I need to rewrite the whole piece, everything. So reusability is important here, and it is much higher in the Skinny design. And the last point, which is, I think, important as well, the point number 4 is testability. Testability. So in this case, if I want to test something, if I want to test how this JSON, let's say I'm a developer of this library and I want to test how it works, then well, maybe for the developer of the library it's maybe easier because the developer has access to all the internal elements from all the internal classes. But still, if you look at this code and you want to see how this library actually can parse some JSON documents, then you need to always start from here, always start from the top line. You always create a reader, and then you feed the reader with a stream, and then you get the object, and then you get down there, and then you check. So basically you have to write integration test all the time. So it's always starting from the top level of the hierarchy, and then you go down into smaller objects, and then you see how that smaller object works, but you start from higher level. In this case, it's much easier because all you need to do, for example, to test this class, you just pass a different line in here and say, let's say this is the string and this is hello, and then you check the title, and then you say assert title equals to hello, and that's it. So you basically, it's much easier for you to test a specific element, not the whole hierarchy, but you test one element. So you pass whatever you want to pass in there, and you test. In this case, you may say that yes, if you are the developer of the library of this one, then probably inside you probably you have this JSON array, I don't know how it's called, maybe it's something like this, JSON array implementation, and then this JSON array implementation probably, but I doubt it, probably takes an input as this. I mean, for the array, it's just an array. I mean, it takes something like that. But I don't think it's true. I think that JSON array implementation in their case is taking as an input for the constructor, is taking the already pre-parsed data structure. So I think the JSON implementation is just a wrapper of a data structure. which is prepared by this guy, by read object. So to test how the system can deal with arrays, you need to test it starting from here. Because of the cohesion problem we discussed earlier, so the functionality is spread over multiple classes. One class is parsing, this one, another method is retrieving, and then another one, well, probably the same is iterating. So it's in multiple places. While here it's pretty standalone. Look, it's JSON string, here's the string, get the value. No dependencies here. No reader, no stream, forget all that. It's pure unit testing. No integration testing, pure unit testing. So I give you the data and show me how you parse the data. If I want to parse larger data, then I use this one. I also give the JSON object some text, and I say parse me that text. So it's much easier for me to unit test that stuff. That's important. I think it's important for testability. How your classes are prepared for tests. I think we discussed that multiple times, that good developers, they are developing their classes, their interfaces, so that they are ready for tests, and that's important. And if you cannot write your test, if it's difficult for you to write a unit test this way, look, this way. If you cannot write a unit test in a simple way, if you need to do the preparation, if you need to do this so-called test scaffolding, when you prepare a lot of things and only then you can test, then it's a problem with your class. It's a problem with your design. So your design has to be test ready, prepared for tests. And if it's not, then it's only your defect, your mistake. So in this case, this skinny design will definitely help you create code which is more testable. Because every class is dealing, and now I'm getting to the final line, to the final point, is that in this design, in this skinny design, every class you design will deal with pure data. I mean, clean, open, naked data, so-called. So in this case, you may say, if you are object-oriented fan and you like object-oriented way, then you may say that here we encapsulate all the things inside, and we don't let data escape our design. So in this case, look, we never return you back the pure text. We always return the objects. Like here, the quotes are coming out, like JSON array. Here's the list. Here's the string. So, but here with the get element method, we just let anyone take the pure data out of the class, out of the object, and then deal with the data. So this is reasonable concern. That really does make sense, saying that by taking the data, we are making them exposed, they escape the object, and then we let somebody else, like this object, work with them again with the data. So here, look, the data was coming here. We encapsulated the data in the JSON object. The JSON object did some parsing, and then we say, give us the data back. And again, it returns the data, and then another class, another object catches this data, and again does some operation on the parsing. And then again, it's possible to take something out and let another class do the parsing. So it may look like not really object-oriented way, because we in object-oriented programming, we're supposed to keep the encapsulation as much as possible, so we don't let the data go out. But in this case, I think that when we deal with situations where objects where data is more complex than just a number, just a string, because here the data is more complex. It's a complex data structure. It's a JSON with multiple levels. Then in this case, I think it's reasonable to let different objects deal with this data from different angles, from different perspectives. So one object, like JSON object, is looking at the entire data structure. This one is looking at a smaller piece of this data structure, and so on and so on. So it's better to do it this way, to let the data move from object to object instead of keeping the entire data structure in one object and then creating these data transfer objects, these data containers outside, pretending that we're encapsulating the data and not letting people, not letting those objects, touch the data. I think this is more like fake object-oriented programming. This is not really object-oriented. It's more like a workaround, because like I'm saying, these things are data structures. I'm telling you, you can check the implementation inside, but I can guarantee you that they don't do the parsing here, or parsing there. They parse only in one place. So there's no streaming, no actual separation of concern. You know what they say in object-oriented programming, separation of concern. So this design does not separate concerns. It just keeps one concern in one place, parsing. And then in all other places, they're just data retrieval. So I think it's better when data is complex, when it's not just one number or one string, but a pretty complex structure. I think it's reasonable to break it down into smaller pieces, this data structure, and let it be managed by objects with special purpose objects. Let's call it this way: objects with special purpose. So that's, I think, is what is important in this design. And one last point is that, of course, in real life, there will be a combination, a mix of these two designs. You're not going to have the pure Skinny design ever, because sometimes you will have compromises. Sometimes it will be easier not just to return the pure data out, not just to let it get out, but maybe do something internally and pre-parse something. Sometimes. And maybe sometimes this design will also be a little bit compromised, and you will be able to do to say something like this. Object, for example, get JSON, something like this. In like JSON, whatever, text, quotes. Maybe you can introduce it there. So there could be, it's not black and white, so it could be a mix. But I am suggesting you to lean towards Skinny design if you can, because like I said, there are 4 benefits in this design. So now let me take a look at your questions and see, maybe you have something interesting there to say. Ali says that the fat design has a mem related to it. It's the banana and the jungle problem. I don't know what that is, but maybe. Another comment is the problem with the Skinny design is that stream is unidirectional. You can't go back. What if the title and quotes elements will be in different order? Yeah, that's an interesting comment. So we're saying that, look, for example, this is the stream, yeah, and we just can parse it only once, and then definitely this one will kind of finish the string, or maybe let's say, yeah, that's let's say we change, we first of all we get the quotes, and then we get the string. Let's put it this way, yeah, like here. So the stream is unidirectional, so you cannot read the stream multiple times. What do we do in this case? We can make pre-cache stream. So something like that, or something like that. So a new class which will let us read the stream, but will let us get back to the beginning of the stream. And when we get back to the beginning of the stream, it will get the data from memory, from cache. So that's it, if we want it this way. Another, what if object is not an object in JSON? What if object is not an object in JSON? Yeah, if there's a mistake, if you look at the Skinny design, if the stream contains some broken object, broken text, then here everything will be okay. The constructor doesn't do anything. We don't need this. And then we say, okay, we say JSON. Let's do it this way. So we say JSON stream get element title. And you're saying that here we get a runtime error because the stream is not properly formatted. That's only better because we are delaying the moment when the problem occurs in runtime. Because in this case, the runtime exception will be here. And this scenario, it will be later. Which is better? The later you raise your exception, the closer your exception happens to the place where it's actually is happening, the better. Because here we say, read the JSON document, and then we say, give us the title. And let's say maybe the title is properly formatted, but the quotes are not. Something like that. Maybe in this example, it doesn't really make big sense because maybe you want the whole document the whole operation to fail right at the place when you read it. But in general, it's better to delay the exception till the very moment where the exception has to occur. I mean, it's in general, the general rule. So don't raise exception when you just, when on a higher level. It's better to raise the exception at a specific level because here we will be able to say that we cannot read the title. So we are trying to read the title, and exactly here, when the title is trying to be taken out of there, the exception occurs. So it's better because the exception will be more specific. The exception will have more information about where is the trouble. Instead of here, it will say just, your JSON is bad. And maybe the reader will be smart enough to say that the problem is next to the title. But in this case, it's better because you will have more information for your exception. The API of the FET. Oh, sorry, another comment. JSON parsing from stream is usually done by SAX parser, an event-based parser, not like getElement. Yeah, it depends on the internal implementation. Yeah, I don't know how exactly they do this parsing from the JSON, but I guess that so you're saying that this getElement may not exist there. Well, no matter what is the parser, but okay, maybe you are able in this case to not return getElement. Don't return getElement as a string. Maybe return getElement as a structure again. So let the structure jump out of the original object. That's also possible. So how this data will look exactly, that depends on the situation. Maybe in my case it's a string, just a simple. This data is a very simple string, but maybe in your case it could be something more complex. Sometimes I have, in some of my applications, I have this XML. So I just let the XML jump from object to object and be the representative of data. So what exactly is data and what's the format we use for data? That depends on your case. That could be string, could be simple text, or it could be something else. The implementation of the Skinny design should be much more complex also. It knows that JSON array starts with a square bracket and returns as a string. Yeah. So that's basically all I wanted to tell you. I don't see any more big questions from you. So think about that. Think about how you design your classes, and maybe you can be more skinny. So you can be more... so don't make your interfaces large. That's also very important for this case, because large interfaces is a problem. When your interfaces are, if they contain more than 4 methods, I told about that many times, then probably it's not a good interface. So in this case, your interfaces will be smaller. It will be smaller because they will only return, in most cases, return data, and then those data will be encapsulated in further steps by smart classes, and that's where you implement all the functionality. So your interfaces will be quite small. You can take a look at this library on GitHub, where we are using this approach to very large extreme. So in this class we have, I think, more than 100 interfaces, and they all very small. They're all skinny. And then we have more than 100 smart classes, which encapsulate those interfaces and deal with the data. Take a look at this library. You will see how this idea is implemented in action. So thank you very much for listening. I see you in a month. So again, we're gonna try, like I said, let's try to do these webinars every month, every first Wednesday of the month. And if I forget that, you remind me, and I will try to be on schedule. I really want to do it every month. Thanks for listening. Come to my blog. You can see announcement there. The link to the blog is below in the show notes. Thank you, everybody. Bye-bye.